Today's section of notes is 10H from your packet. It is on quadrilaterals, and specifically we're going to look at rectangles and rhombuses, or rhombi, or rhomboids, which all happen to be correct, and we're even going to look at squares at the end of the unit. Let's start with characteristics of things that we know in general of quadrilaterals. Things that we know, all quadrilaterals have four sides to them. We also know that all quadrilaterals have four angles whose sum, not sum like that, is 360. All right. Um, let's list kind of quickly. We know all the names of the quadrilaterals. We have a square, we have a kite, we have a trapezoid. We know that we also have an isosceles trapezoid, by the way. We have a rectangle, we have a rhombus, and we have a parallelogram. All right. And that's in no particular order. Those are just the six quadrilaterals that we're going to look at, or we've been looking at in this unit. Okay. So go ahead and get those. If you need to pause the video, feel free to pause it. I'm going to move on to the next slide. Let's list what we know about a parallelogram. There are things that we know about both the sides and the angles, and then we're even going to add the diagonals of a parallelogram. On the sides, we know that there are two pairs of parallel sides. We know that there are also two pairs of congruent sides, and those are the sides that are opposite each other, of course, for parallel and congruent. For the angles, we know that opposite angles are congruent. And we also know that consecutive angles are supplementary. So go ahead and add both of those. I'm going to add another section here for the diagonals, because we want to make sure we have some things straight and squared away about the diagonals of a parallelogram also, and the diagonals of quadrilaterals in general. So about the diagonals of a parallelogram, we know that they bisect each other. No need to underline that. Okay, so the diagonals bisect each other. In previous sections, we've talked about 5 ways to prove a quadrilateral is a parallelogram. So we know some things, some ways, some methods, so to speak, of ways to prove that a quadrilateral is a parallelogram. So we're going to list those here. We know that one of the ways is if one set of sides is both congruent and parallel. Okay, that's probably one of the more difficult ones, the one that students oftentimes forget. We know that if both pairs of opposite angles are congruent, so that's a second way. We know that we can prove it if the diagonals bisect each other. We know if the consecutive angles are supplementary, we can prove it. And we know that if both pairs of opposite sides are congruent. And then we want to kind of list corresponding pictures for each of these. Sometimes for some of you guys, the pictures are way better than the definitions, because it allows us to kind of put something that makes a little bit more sense to it maybe than just the words to go with it. So we're going to do that. Not 33, obviously. Alright, so let's get some pictures here. We have that all spaced. Let's get a parallelogram, which I don't have, so we'll freehand draw. This will be exciting. Try not to be overwhelmed with my drawing skills here. And then so that we are exactly correct, we'll just duplicate these. And because I created opposite sides congruent, I know that that's a parallelogram, even though I've measured nothing or taken, the slope. I know that these two sides, when I created them, were congruent, and these two sides were congruent. So I know that that's a parallelogram. So let's go ahead and uh, put 5 of these on here, and then we'll label them according to what we said about them in the corresponding number. And I'm going to put that one right there. Let's move you. Alright, so what we need to label, one set of sides is both parallel and congruent. For that to be true, or to label that really, one set of sides, if that was congruent to that, let's go ahead and make this a different color so you guys can see it. If this is congruent to this and parallel, then that is a parallelogram. If both pairs of opposite angles are congruent, so we need angles to be congruent. So let's go ahead and for this we'll draw, so this is sure to get messy. If that is congruent to that, and that is congruent to that, then that's a parallelogram. If the diagonals bisect each other, so let's go ahead and add the diagonals to our drawing. Um, so let's go one right there and one right there, and then to show that they bisect each other, we'll mark this congruent to this and that congruent to that. So that's another way that shows it. Consecutive angles are supplementary. I think probably the easiest way to do this is to just get some numbers down for these angles, and then we can say some things about each angle in reference to its number. So if we just number the angles 1, 2, 3, and 4, or however you want to number them, if your favorite numbers like start in the mid 70s, like 76 or 77, then that's weird, but we'll start here with 1 in this crazy scheme to make sense. So if we said that 1 plus 2 equals 180, 2 plus 3 equals 180, 3 plus 4 equals 180, and wait for it, the suspense is killing you, I know, wait for it, and 1 plus 4 equals 180. So if those things are true, then there again we would have a parallelogram. And then lastly, both pairs of opposite sides are congruent. That's probably the easiest one. That's just if that's congruent to that, and that is congruent to that. Alright, let's take a look at the next page. We're going to talk specifically here about rectangles. So we have a rectangle. A rectangle is a parallelogram. It's one of our parallelograms that we're talking about in this section of notes. So all the things that are true about a parallelogram are true for the rectangle, but also, well, first let's add those. So we have two pairs of parallel sides. We have two pair of congruent sides. The angles of a rectangle are different than the angles of a parallelogram in that while the opposite ones are still congruent and the consecutive ones are supplementary, more specifically we know that all the angles are right angles. Um, so it's just more specific. And then we're also going to add a section about the diagonals here, because the diagonals of a parallelogram, I'm sorry, of a rectangle are congruent. So, so now we're going to label the rectangle with everything that we know to be true about it as far as the angles and the diagonals and everything. So we'll start with the right angle. So all four corners, all four angles are right angles. We know that opposite sides of a rectangle are congruent, so we'll label those. And then we know that the diagonals of a rectangle bisect one another, so we'll label those. And that's everything we can label from what we know about a rectangle and its properties. Okay, so now on the next page, we're going to work through some of these examples of finding the values of the variables together. Most of these are pretty simple as long as you remember some basic things you know. This first one, we know that all the angles of a rectangle are 90, so we can say that A and B equal 90. That's pretty easy. And then Y, we know that Y equals the opposite side, so we know that's 10. Go ahead and take a second and see if you can't set up at least this rectangle right here on the bottom left. Just try to do the best you can and set that up. I'm going to go ahead and start doing the problem. If you need longer, go ahead and feel free to pause it right here to finish setting up the problem. But we know that the diagonals of a rectangle are congruent, and that they bisect one another. So we can say that, and actually, I'm sorry, let me go back real quick just to be clear. These sides here, while they are congruent, they're congruent to each other also. So we didn't need, sorry about that, we didn't need those two marks. Here we can say, because of that last fact, that 5y plus 2 is equal to 3y plus 12. From there, you're going to use your wide array of algebra skills. Subtract 3y from both sides, subtract 2y from both sides, or from 2 from both sides to get 2y equals 10, and then y equals 5. On the rectangle on the right, you can see that from just a little tiny piece of information, using what we know about both rectangles and triangles, we're able to solve for all sorts of variables. So take a second and try those while I make a list of all the variables that we're going to solve for. So starting with A, if we know that that's a right angle and part of it is 25, then we know that A is 65. We know that B is the same as A, so that's 65. We know that because these two triangles right here are, these two sides right here are congruent. So this is an isosceles triangle. If you can just look at this one triangle, and the base angles would be congruent because these two legs are congruent. Once we know B, we know C is also 25. D, for the same reason we have another isosceles triangle, that's 25. E is the same as B and A, so that's 65. F is 25. I'm sorry, F is 65 also. G is 25. Figuring out H is a little bit different. When you figure out H, we have these two angles right here are both 25, so that's a total of 50. If this top triangle's interior angles add up to 180 degrees and 50 is used up, that means we have 130 left. To solve for that angle, it's just 180 minus 25 minus 25, and that gives us 130 for H. I is a linear pair with H, so that's 50. J is 130, and K is 50 also. Alright, let's take a look at the next page. On the next page, we have some more examples of things that we know about rectangles. Because this is 12, we can say pretty quickly SH is a fairly easy one. We know that that's 12 also. AH then becomes the sum of those two, so 12 plus 12 is 24. If this is 15, MH is also 15, so we know that's true. We're not asked that in here, but just for some information, if that's 15, this opposite side is 15. MS, remember all these parts, okay, all these parts of the diagonals are all congruent. So MS is also 12. and MT is the sum. Well, we know that ST is also 12. Okay. Um, and then we know that MT is their sum, which is 24. Fooled you with that one. Finding HT is a little bit more difficult. We're going to have to actually use some information that we know but isn't shown. We know that this is a right angle. We know that this is 15. You can't see that, so let me undo that and change colors for you here. We know that this is 15. We know that this is 24, and we're looking for this right here. Well, what we're able to do is set up the Pythagorean theorem for that problem then, and just say that HT squared plus, we know that this side here is 15, and 15 squared is 225, is equal to 24 squared. Well, what is 24 squared? I'll wait. So 24 squared is 576. From there, you're going to subtract 225 from both sides. So we have HT squared equals 576 minus 225 is 351. And then we're going to take the square root of 351 to solve for HT. So HT equal, you get a decimal here, but we'll go ahead and round it, and we'll say 18.7. We'll just round to the 10th. So we did all that work there. I'm going to make this smaller so you can see it and still see your work. So we'll say 18.7. Alright, so there's that. Let's take a look at this next problem. On this next problem, we're given that EGO, this angle right here, EGO is 5x. I'm going to go ahead and write 5x for that angle there. OGM, this other angle here, is 4x. And then I just have to use my knowledge of rectangles, and I know that that angle right there, when I add the parts, I can add these together to get the sum using the angle addition postulate. So I know that 5x plus 4x has got to be equal to 90. And then again, I'm going to use my algebra skills there and get x is equal to 10. So not too complicated. This next problem, we have BD, that's this entire diagonal, is equal to 6x minus 10. And then we're just told that BE is 2x plus 8. So there's some steps to this problem. We're going to double BE to get the whole diagonal, set that equal to BD, solve for x, and then plug it back in. So it sounds like a lot of steps. It's really not too bad. BD is 6x minus 10, and that's going to be equal to 2 times 2x plus 8. On the next line, I'm going to divide both sides by 2, so I'm left with 3x minus 5 is equal to 2x plus 8. There's more than one way to solve that, but my algebra skills tell me to, and that's a 3 back here. I said 2 and I meant 3. My algebra skills tell me that it's easier if these numbers on the left side of the equation are both even to just divide both sides by 2. On the next line, I'm going to subtract 2x from both sides at the same time that I add 5, and I'm going to get x equals 13. Now the problem isn't done there because it told me to solve for BE. So I'm going to take the 13, plug it in right here. 2 times 13 is 26, plus 8 is 34. So there are those example problems done. If any of those problems give you trouble, you should see your teacher or ask for those examples to be gone over in further detail in class. Let's go ahead and take look at the next slide. A rhombus is another kind of parallelogram that we know all sorts of things about. All of the information from your previous slides about parallelograms are true. And then we're going to add some facts. We're going to add things like all sides are the same length. We know that that's true. But then our other facts that we have about parallelograms still remain true. So, um, two pairs of parallel sides, obviously. And then for the angles, the same things are true. Opposite angles are congruent, consecutive angles are supplementary. So both of those things are still true. And then we're going to add a section again about the diagonals. There's one new thing about the diagonals of a parallelogram, and that is, well, first we have the old one that the diagonals bisect each other, but they are also perpendicular. They're not congruent necessarily, but if they are, that's a different kind of shape, but they are perpendicular and they do bisect one another. So let's take a look at this rhombus. There's lots of things now that we're able to label um, on a rhombus. So let's go ahead and start doing that. Oh, sorry, there's one other fact about the angles I forgot. So go back to the page before real quick. Um, the angles, well, and we could add it to either the angles or the diagonals. The diagonals bisect the angles. Um, you can just say they bisect the angles. It would probably make more sense once we look at the picture. So let's go ahead and do that. First, let's start labeling all of our diagonal parts congruent. So let's start by these diagonals. We said they bisect each other, so those two are congruent and the other two are congruent. We know that the diagonals are perpendicular to one another. We know that all the sides are congruent, so we can just mark all those. Mark all those congruent. And then that last fact that we said about the angles being bisected. So that angle there is congruent to that angle there, which is also congruent to that angle there and there, because opposite angles are congruent, so when they're bisected, their parts are congruent also. And that angle is congruent to that angle, and that angle is congruent to that angle. So essentially in a rhombus, once we draw all of these things in, we can notice sometimes that what we have are four congruent right triangles. Okay, it's important to notice we have four congruent right triangles. Let's go and take a look at the next slide. So things we know about a rhombus now include all of the things from the slide before. So literally, once we've now drawn it, we wrote some of these things, we didn't see them last time, so this slide is what we're talking about. We want to add all these facts to things we know about a rhombus. Okay, I'm going to let you go ahead and do that right now. So hopefully you have something like this. I added this last part here. This is that they create four congruent right triangles. It's helpful sometimes for some of the problems that we're going to solve or parts that we're going to look for to remember that when the diagonals are drawn in there, we have four congruent right triangles. So let's take a look at these examples. Some of these, are problems that we're just practicing our basic skills so we can build up some knowledge base. We know, really easily that A, B, and C are all 5 because of what we know about, because we know rhombuses all have the same side length. Hold on one second, I have to smack a kid. And that student survived, barely. Let's take a look at this next one. We know that these angles here, this diagonal bisects these opposite angles. So if this is 25, so is B. Usually we can work in alphabetical order, but this is one where we're actually not going to. We know that A and C are the same because they're opposite angles in a rhombus. So A and C are the same angle. But how are we going to solve for those? Well, we know that there are some congruent parts here. This is congruent to this, these two sides, because it's a rhombus. And if you can just look at this top or left, however you want to view it, shape, this becomes a triangle, an isosceles triangle with angles of 25 and 25, so that's 50. So there are 130 degrees left for angle A, and C is congruent to that. So A and C are both 130. You can see, similar to the rectangle problem we did like this, that just given one part of one angle, we can solve for all sorts of things. So go ahead and take a second and do that while I make a list of all the angles that we're going to solve for. Pay no attention to the noises you hear in the background. People in my room are throwing things. Alright, so let's take a look here. From 28, we know that 28 uh, is this angle here, but it's also angle A, because that angle is bisected by the diagonal. So that's 28. We know that angle B, we can find angle B because D, L, G, and I are all 90. These because the diagonals are perpendicular. So if D is 90 and A is 28, that's 118. B is whatever's left over. So 180 minus 118 leaves us with 62. We just said that D is 90. E and B are congruent, so E is 62. F and A are congruent, which is 28. G we said is 90. H is the same as F, so that's 28. I we said is 90. J is the same as E, which is 62. K is the same as J, which is 62. And L is 90. So just from one angle in a rhombus or a rectangle, we're able to solve for all sorts of other angles. If we take a look at the next page, what we have are some more rhombi examples. Here we're given that the measure of AED is 5x plus 5, and we're told to find x. Really what you just have to remember is that in a rhombus, the diagonals are perpendicular. So once we label that as being perpendicular, if AED is 5x plus 5, we can very simply say that 5x plus 5 equals 90. From there, you're going to subtract 5 from both sides and get 5x equals 85, and divide both sides by 5 and get x equals 17. So not too hard of a problem as long as you know your rhombus properties. That is better. Okay. Let's take a look at this one right here. It says that ABC, so this angle ABC right here is 6x minus 2, and ABD is 2x plus 10. What you have to remember here is that ABD is congruent to DBC. So ABC, this larger angle that we have, is equal to the ABD doubled. So that's all we have to do. So to set that one up, we would say, I'm going to go ahead and put ABC, so that's 6x minus 2, equals 2 times 2x plus 10. Now earlier we had a problem where I divided both sides by 2, and that's possible again here, but since we did that the first time, I'll go ahead and do this one differently just so you can see it both ways. 6x minus 2 equals, and then I'll distribute and get 4x plus 20. Subtract 4x from both sides and add 2 to both sides, and I get 2x equals 22, so x equals 11. So again, another relatively simple problem algebraically, as long as you remember the facts and the properties that you know about rhombi. Here we have AB is 5x minus 10 and BC is 2x plus 2. You just got to know that in a rhombus all the sides are congruent. So we can really simply just set those two equal to each other. Add 10 to both sides, subtract 2x from both sides. We get 3x equals 12 and x equals 4. So not real complicated, just as long as you can remember these properties and apply them when they're appropriate. Let's go ahead and take a look at the next page. Here, this is just a formula that you need to remember. The area formula for a rhombus is just 1/2 times diagonal 1 times diagonal 2, and it's 1/2. This is the same as like 2 times 3 times 4. We're not going to distribute the 1/2 to each of the diagonals. That's a really common mistake. So you just want to make sure it's just 3 numbers: 1/2 times diagonal 1 times diagonal 2. So if MA, if this distance right here is 8, and DMA is 30. Okay. Um, Here, we're going to have to use what we know, either using special right triangles or trigonometry, to find this missing distance. Okay, to find that missing distance. So I'll give you a second and write down the setup for how you're going to do that. And then we'll look at finding, we got to find the length of DA, double it for the length of DL. We already know that one of the diagonals, that MK is 16. So MK equals 16. We need to know DL. And to find that, we're going to need to find DA. So to find DA, I'm just going to use trigonometry. I'm going to say that this is the opposite, and that is the adjacent. So I'm going to say that the tangent of 30 is equal to whatever DA is over 8. And that doesn't look very good, so let's change the way that looks here. So it's DA over 8. There we go, that's a little bit better. So we can at least see everything. And then I'm going to, so I'll just take my handy calculator here. And make sure that I am in degrees right there, not radians. So I'm going to multiply the tangent of 30 times 8. And just for ease, I'm going to round it to the, let's just say to practice our rounding, I'll round it to the hundredth. So I'll say 4.62. So I'll go back here, and I'll say that DA equals 4.62. And then so DL, I'm going to double that. So that becomes, and just real easily we can double it right in our calculator. It becomes, and I had 4.62. Let's double what we rounded it to, just so we can all see. So it's 9.24. It was 9.24 here when we round also. So DL is 9.24. And so we're going to multiply the area is going to equal 1/2 times 16 times 9.24. So the area of this rhombus, and again we'll use our calculator here, I'll do 1/2 of 16 is 8, so then 8 times that 9.24, and I get 73.92. So 73.92 is the area there. Okay, let's take a look at the next page. One thing, and I know I just clicked the next page, but one thing to make sure is that this doesn't work in every parallelogram. This works specifically in a rhombus because in a rhombus we know that this is a right angle. So I'm able to use right triangle trigonometry. Okay, just a reminder there. A square. A square is multiple parallelograms. A square is it's a rectangle. A square is a rectangle. A square is also a parallelogram, and it doesn't really matter what order we put these in. We're just trying to make the point that a square is a combination of all of these three. Okay. As a result, all of the properties of those quadrilaterals apply to the square. I'll let you list those. I think it's almost better to understand it pictorially. So you're going to list them on your own. You can copy them from the other pages of the slides. What I want to do is show you what it looks like when we list them, or when we label the square itself, just so you can see all of the different things that we're able to say about a square. So there's the square. And then what I'd like you to see is we'll go ahead and label each part. So we know, for example, that all the sides are the same. That's something we know. We know that a square's diagonals bisect each other. So let's draw those in. We know that those are all congruent. We know that these are right angles in here. Okay, so we know that that's true. We know that opposite sides are parallel. And then there's also a fair amount that we know about the angles. Um, we know that this angle and this angle are congruent. We know that all of these angles are congruent to one another. Okay, and we also know, I'll just change colors just so we can kind of see it. We also know obviously that these are right angles, all of them. So lots of information on a square. You should go in and list out all of the properties that we've listed through all these slides for sides and angles, but I wanted you to see the square as a drawing with it labeled so you could see what is what. Here, because of that, there's some relatively simple problems and some relatively complicated problems for squares. Um, we know that um, A, B, and C are all equal to 5. And then we know that D and E are both equal to 90. That's pretty basic. Um, this problem right here lists a ton of things, but it's not real complicated actually. We know that A, B, C, D, H, I, J, and L are all equal to, that's right, 45. And we also know that E, F, G, and K are all equal to, wait for it, you guessed it, 90. Okay. Um, so those are pretty simple. This gets a little bit more complicated here just because you have to remember something that, sometimes when it's angles, sometimes can be easier with a square. But if AB is 12, then AE, how are we going to find that? And BD, so we're given one part of it. You can do it a couple different ways. You can use Pythagorean theorem. You could use special right triangles if you wanted to, or you could use trig, really, any way works. On this problem, what we get is, yikes, what we get is, if we're looking for this piece right here, that's what we don't know, because once we have that, we can double it. Well, that is AE, and we can double it for BD, and it's also equal to EC, so we need that part, and we don't know it. We just know that these two are the same, and that's 12. Well, what we're able to do is just use the Pythagorean theorem. Because I know that this is a right angle right here, I can use Pythagorean theorem. So I'm going to say that x squared plus x squared is equal to 12 squared, which we know is 144. And then that becomes 2x squared equals 144. I'm going to divide both sides by 2. And so I'm left with just x squared equals 72. And then I'm left with x equals, and I'm going to leave this as a radical in simplest form just because it's faster for me. But read the directions on your test, quiz, daily check, classwork, whatever it is, and make sure that you have it correct. See what your teacher wants you to do. But I take the square root of both sides. I get the square root of 72, and that's equal to 6 times the square root of 2. Okay, and that is slightly bigger than what we need. So we're going to put that there. So this is 6 times the square root of 2. So given that, we can fill in the rest of our blanks here. AE, that is our 6. And then let's see if this will work. I don't want an arrow, please. Math, of course not. Alright, so we'll go ahead and just put it in. That's 6 times the square root of 2. And we'll fix the size on that in a second. BD is double that. So BD is just 12 times the square root of 2. So let's go ahead and fix the size on those because that doesn't fit. So that's that, and BD is that. EC is the same as AE, so you can just copy that answer over again. So those are the missing sides there. Let's take a look at the bottom middle problem. The bottom middle problem tells us that AC is 6x plus 12, so one of the diagonals. BC is 5x plus 5, and it wants us to find the length of AC. So what we're going to have to do is we're going to have to solve for x. We have to solve for x and then plug it back in. But not too hard because we know that the diagonals are congruent. So 6x plus 12 is equal to 5x plus 15. We're going to subtract 5x and 12 from both sides at the same time and get x equals 3. Now once we do that, that's insane. All right. Once we do that, we can just plug the x back in to AC, where x is right here. So 3 times 6 is 18 plus 12, and we get AC is equal to 30. So again, not too hard. Here, ABD is 9x. Well, we know that the diagonals of a right triangle bisect the angles, which makes each one of them 45. So it looks, like maybe it's a tougher problem, but really it's just 9x equals 45, so x equals 5. All right. So next page is really just information for you, some really just things to keep in track, keep mind of when finding sides, angles, the diagonals, or the value of x. These are some things to keep in mind. First, determine the type of quadrilateral. This, I think, your teachers would all stress is the most important thing. Rectangles have things, that apply to them that don't apply to rhombi, and vice versa. So make sure you know what kind of quadrilateral it is. Determine what characteristics you know for that type of quadrilateral and mark the diagram accordingly. I think marking the diagram is probably the number one thing that students miss out on, that if they did, they would make fewer mistakes. Write the equation based on the characteristics. Set up an equation. Not every equation is equal to 360. Not every two expressions are equal to each other or whatever. But so be careful. This is probably the most important of geometry. Probably all your teachers would agree is that we set up the problem correctly. Okay, so write the equation correctly. And then obviously solve the equation. That makes sense. The last part, I'd say make sure you find what the question is asking for. Sometimes you have to plug it back in and find the length of a side or an angle or whatever. All right. This has been great fun. I can't believe our time here is over. I'll miss you all dearly. See ya.